Section 1. In this section, we'll be learning how to configure nconf. nconf is an open source tool which is used a configuration module. We familiarize ourselves with Winston. It is a logging library which we'll use to log various aspects of our application. And installing Nginx, which is an alternative templating language that to be used with Express. Config.js is a configuration module that helps make your application flexible. Configuration is important as it helps keep magic numbers out of our application. We can even create multiple levels of configuration that override each other, providing smart defaults, whilst you keep your production configuration secure. It's worth mentioning that there are alternatives to nconfig out there, but nconfig is the biggest library available. It has thousands of users, and is developed by Flatiron, a well-respected node development company. Let's start with an empty Express application. To do this, we need to install Express Generator. Once that's installed, we can just run Express to have an application generated for us. Don't forget to run npm install to install the dependencies for our application. At the moment, the port our application runs on can either be set in the environment or it's hard-coded to port 3000. This works well for single-wire value like the port to listen on, but it can become a little hard to follow with lots of configuration options. Imagine that we have some logging in our app, where we want to change from logging debug messages to only logging errors. Each time we want to change these values, we need to either change our environment or redeploy our application. Wouldn't it be much easier if we just had to change a config file and restart our app? First, we need to install the package from npm. To do that, we use npm install nconfig. Once it's downloaded, we can start using it. Nconfig comes with 5 different ways to load configuration. argv, which is the command line, env, which comes from the system environment, file, defaults, and override. Defaults and overrides are ways to specify values directly in your application. Of the 5, argv, env, and file are the more interesting. You can specify which order they should be read from, meaning that you can say read from argv, then if it doesn't exist in there, try the environment, then our config file, then finally use the defaults we specified, if you can't find it anywhere else. So, for example, if we have a port number defined in our defaults, in a config file, and in the environment, the one from the environment will be used as it overrides the file and default options. Let's replace the existing hard-coded values in our app so that they read from nconfig instead. To do this, we'll utilize nconfig defaults. But first, we need to include our module so that we can start using it. So, let's edit app.js. At the end of our imports, we'll add var nconf equals required bracket nconf close bracket. Next, we'll add a call to nconfig.defaults to set some of the default values. The hardest part about this is trying to think of the names for the configuration options. Here, I've created the HTTP namespace and specified the port we are going to listen on, in this case, port 3000. Next, we need to update our www binary to this value. So, let's open bin www and look for where we set the ports. So, app.set, port, we need to change this to nconf.get http :port. Colon is the namespace separator for nconf. We can also delete the line before because we don't need it anymore, and save our file. As this is a different file, we don't actually have access to nconf, so let's jump to our requires and add nconf, just like we did in app.js. Express previously used app getPort to say which port the server should listen on, but recently they have changed it to just using a port variable. Let's change that back. Now, we should be able to run our app just like normal. It should work just the same. The debug variable here is saying enable Morgan logs. Morgan is the logger for ExpressJS. So it says anything in the mastering Express application development namespace I want to see. As you can see, our Express server is now running and it's listening on port 3000. Now that we've got nconf installed and we're using it, let's start customizing things. I've created a file called config.json that has the same layout as our nconfig defaults block, an HTTP namespace and a port. But this time, I've set the port to 8000 rather than 3000. This is to show that the port will change if we tell our application to use the config file. Let's tell nconfig that we want to use this configuration file. So, back to app.js, and before we specify our defaults, we want to say our configuration file has a higher precedence. So we declare it before the defaults block, and here, I've just used nconfig file and passed in config.json. You can pass in a path to any file that you like. If we save that and then we start our application again, we can see that instead of listening on port 3000, we are now listening on port 8000. Congratulations! We've got 2 levels of configuration being loaded. But why stop there? Our config file should override defaults, but we should have a way to override that too. Let's use environment variables to do this. Unfortunately, the colon character that nconf uses for namespacing isn't valid as part of a variable name. So when we enable nconf env, we need to specify a new delimiter. By convention, we use a double underscore. Just like always, when we make a change, we want to make sure that it works. So let's go and restart our application. As expected, it's currently running on port 8000. If we change this and add an environment variable, our namespace is HTTP, and then we add our double underscore and we type port. You must set this to 8001. As you can see, our application is now listening on port 8001. Finally, let's have a look at command line options. These are values that the user can set that will override everything else other than the overrides section. When adding a command line option, you tell us what the command line flag should be, what configuration option it translates into, and the description of the flag. Again, we want to prove that it works, so let's start our application normally. It's still port 8001 as it's coming from the environment. But if we pass our -p flag, as you can see on port 8002, we can see that the port that the application is now listening on has changed. This is because the command line flags have a higher precedence than the environment. Sometimes, though, there's just some values that you don't want anyone to change at the minute. Eventually, they might become config options, but for now, you want full control over them. This is where nconf overrides comes in. You can use config values just like you would normally, and then hardcode the values using nconf overrides, safe with the knowledge that no one else can change it. And then, when you are ready for things to become configurable, you can remove the overrides section. Again, we want to make sure that things are working, so let's start our application. That reminds that we now have our default of port 3000, our configuration of port 8000, our environment of port 8001, and our command line flag of port 8002. But when we start our application, it's listening on port 9000, which is what we specified in our override section. As we don't want to override the HTTP port at the moment, I'm just going to remove this and save the file. Whilst developing, we are going to be working with the config file's default. So our application would be running on port 8000. nconfig lets you change your application's behavior without having to redeploy it every single time. It supports multiple levels of inheritance, as well as overrides for fixing options that you don't want people to change temporarily. Next time, we're going to take a look at Winston, a logging framework. Hey there, welcome back to Mastering Express Web Application Development. Last time, we looked at nconfig and how we can make things that were previously hard-coded magic numbers controllable at runtime. Today, we'll be looking at Winston. Winston is a multi-transport logging library for NodeJS. We'll think about why we need logs and then learn how to instrument our application with Winston and how to control what gets logged in various different environments. There are lots of other options for logging, such as Bunyan and the built-in console.log. But after trying lots of different projects, Winston feels like the most powerful to me. We should probably start by understanding why we need logs in our application. Logs are a fundamental part of our application development. Generally, they're used to help us diagnose what happened when something goes wrong within our application. One very useful application of logs is when there is a problem in production, but you do not want to expose errors to the users. Logs allow you to get the debug information without giving anything away to the user. Why stop there though? Why shouldn't we log everything that happens within our application? Having an application log makes it really easy to work out what's going on inside your application at any point in time. As always, we need to install the package from npm. In this case, we need to use the npm install Winston. We pass --save to save it to our package.json file. Once it's installed, we can start using Winston. Let's start by editing app.js and requiring Winston. As well as requiring Winston, we are going to add a log message to make sure that it works. I'm just going to go to the bottom of our nconfig definitions and write a message that says we've initialized nconf. Let's start our application to make sure that worked. There we have it, info initialized nconf. As well as logging simple strings, nconf has support for logging complex objects. I'm going to add another log message here, which logs our HTTP config from nconf. So if I restart our application, we can see that at the info level, our HTTP config is being logged out, and we can see that our application is running on port 8002. So let's delete the command line flag and the environment variable. And make sure that our application starts, which it does. That means in future, when we want bin www, our application will be running on port 8000, just like we expect. So, Winston info, what does that actually mean? Info is a severity level, saying that this is an informational message. Winston ships with a default set of log levels. In order of severity, the default levels are silly, debug, verbose, info, warn, and error. This means that an error is more important than a warning, and a warning is more important than informational messages. When you start your application, you can tell Winston which levels you want to log, meaning that you can go crazy with debug logs in development, but only show warnings and errors in production. That way, you won't end up with log files that are hundreds of megabytes and even gigabytes big. By default, Winston logs to the console. This is great for development, but maybe you want to log errors to a file for review later, whilst still showing everything in the console. Winston makes this easy. Let's do that now. So, edit app.js, and after we've required Winston, we want to customize it a little bit. We say Winston, add a new file transport, and we're going to log error.log. And we only want to log anything that has a severity of error or above. Now you show that in action. I'm going to add a call to Winston error, saying that something went wrong. I'm going to start our application. As we can see, the error is logged and the info is logged. However, if I show the contents of error log, only the error message is in there. The informational messages aren't stored. This is because we said the minimum level to log is error. Let's remove that now. As well as logging, Winston also provides a simple profiling mechanism. Winston Profile takes an identifier as the first parameter. The first time it's called, it starts a timer, and when it's called again with the same identifier, it stops the timer, logging how much time elapsed between those two calls. In this case, I'm going to give a timeout of a second, and when I run my application, there we are. We see at the info level, the identifier test had the duration of 1002 milliseconds. That's about the second that we expected. Again, let's remove that as we have no use for it. By default, Winston only comes with two transports, console and file. Fortunately, there's a large ecosystem of third-party loggers available, including Loggly, React, MongoDB, SimpleDB, Email, Graylog2, Papertrail, and Cassandra. To use them, just install them via npm and require them in your app. I've decided that I want to get all of the errors emailed to me, so I'm going to install Winston Mail. Next, back to app.js. Here, I require Winston Mail. I don't assign it to anything.
This is because Winston transports generally add themselves to winston.transports.
So, just like before, I make a call to Winston add, this time with Winston transports mail as the third parameter.
As the second parameter, there's a list of options which are available on Winston Mail README on GitHub.
The first is who do you want to send the email to. The second is the username for the SMTP server, and the third is the password. There are lots of other options, but they come with smart defaults. Finally, we need to set the level that this transport should be activated on. As I only want errors emailed to me, I've put error in here. I should add that using npm to install the transports only installs the code required to send the logs to each destination. For example, if you use MongoDB transport, you have to install MongoDB first before it will work.
Yet again, I'm not going to do this whilst developing the app, so I'm just going to clean things up a little bit.
I've just removed Winston Mail from my application. By default, Winston uses the logging levels defined by the npm, which we saw earlier. If the built-in logging levels aren't enough for you, Winston makes it very easy to create your own. All you need to do is define a list of levels and any colors associated with them. Then, when you create a logger, set it to use your custom logging levels. Any levels you create will automatically be created as functions on the logger, so in this case we can call custom_level_logger.bar. Something that the Winston documentation on custom levels fails to mention is that you have to give a new logger a transport, otherwise it doesn't know where to send the messages. So let's do that. You can add multiple transports to a new logger instance, but here we've just said send it to the console. And as always, when adding a transport, you have to tell it what level to activate on. In this case, I've chosen foo, our lowest custom level. Let's see that in action. Start our application, and there it is, the first message, bar. This is an example. Again, this isn't something that we are going to be using much, so I'm just going to go and remove it from our application. That brings us to the end of our Winston tour. There is still one more thing to do. When we add the file transport, we specify that we should log everything error and above. Wouldn't it be great if that was configurable? Let's make that happen. So we start by moving the Winston add call to below nconf definition. Next, we change the hard-coded error string to be a call to nconfig get. And we'll say, get the value in logger file level. Finally, we need to add logger file level to our nconf defaults. Now, if we run things, it should work just as it did before, where everything error and above is logged to a file, but everything else comes to the console. Conclusion. Winston is an awesome library for keeping track of what's going on inside your application. You can use it as little or as much as you like. You can use it just like console log if you want to, but you can do much, much more. Next time, we'll actually start to build our application.
We'll be installing Nginx, my templating framework of choice, and configuring it to work with Express.
Hey, and welcome back to Mastering Express Web Application Development. Now that we've done our groundwork of setting up our configuration and logging systems, it's time to make our application do something. Until the latest version, Express supported Jade, handlebars, and EGS by default. However, the latest version is even more decoupled, which allows us to use any templating package that we want. In this video, we'll be installing Nginx, an alternative templating language that can be used with Express, and we'll integrate it so that we can use it in our application. By default, Express ships with Jade, which we can see in our app.js file. You can find the Jade template in the Views folder, and they look like this. If you're not used to Jade, this can be quite confusing. Personally, I like to use the one called Nginx, which is heavily inspired by the Python templating language, Ginger 2, as I use similar templating languages when writing other programming languages. Let's start by loading up our app and see what it looks like currently. As you can see, it's just an Express header with the words "Welcome to Express." The Jade template has actually been compiled down to normal HTML. This is what we're going to reproduce with Nginx. We start with npm install nginx --save. This must be feeling very familiar by now, but before we can use anything, we have to download and install it. The next step is to configure Nginx in app.js. As Express is a huge project, Nginx actually knows how to configure itself for Express. Here, we pass the app instance into Nginx, and everything is taken care for us. We also say that we want to automatically escape, and HTML is open in our views. And all of our views are currently located in the Views folder. The next thing to change is the view engine. At the moment, this is set to Jade, which means that Express will automatically try and render index Jade when told to render index. Let's change that to HTML, as that's the suffix our files will use when we write our Nginx template. And finally, let's rename all those Jade templates to HTML. If we now run our application or load our application again, we can see that the Jade template is being rendered as though it is HTML, and it doesn't look very good anymore. That means we need to change our templates to use the Nginx syntax rather than the Jade syntax. I think we should tackle the layout first. So let's open Layout HTML and say this HTML document has got a head tag with a style sheet and this block content. A block is somewhere that you can put content. In this case, it's actually called content. Nginx has a similar concept, which I'll introduce you to soon. But for now, let's just delete this file and put our HTML in here. We need to tell Nginx where we want our content to go. In this case, we want it between the body tags. To do this, we have this special syntax where we say, this is a block and it's called content. We use this when we come to fill our index HTML. Speaking of which, let's do that now. Open index HTML and delete everything again. Now, when we start this file, we want to say that it extends layout HTML. Then, we want to design a content block. Whatever we put in between these two tags will be shown inside the content block in our layout. We'll just say, Express, welcome to Express. If we restart our application and we visit the page, it looks just like it did before, the same HTML. We've got a new title in here, and it says, Welcome to Express. Last but not least, let's take a look at the error template. Again, let's just delete the Jade template and replace it with our Nginx one. We extend layout HTML, we name our block content, and this bit looks a little bit different. These are variables in Nginx. Anything in double curly braces will be expanded to the variables that's passed in. If we take a look at app.js, anytime there's an error, we pass in a message and the error object itself. Then we just show them error and the status, and the stack from the error object. Let's see that in action. So our application works like normal, but if we try to visit a page that doesn't exist, we see an error page as expected. Conclusion. Express is extensible. It supports anything that adheres to the conventions that it defines. Today, we learnt about one of those, Nginx, a powerful templating engine based on Jinja 2. Don't be afraid to explore and see what else is out there that you might enjoy working with, more than the defaults. Next time, we are going to be taking a look at how we can consume the Instagram API and integrate it into our application. See you then.
Hi, and welcome to Mastering Express Web Application Development from Pack Publishing. I'm Michael Heap, a developer from London, England.
Welcome to Mastering Express Web Application Development.
I've been a developer for about 10 years now, and I started shipping Node code to production when it was only in version 0.6. For the last few years, I've been working with real-time data pipelines, filtering and augmenting data for customers. This course assumes that you have a working install of NodeJS and are familiar with NPM. No prior knowledge of ExpressJS is required. IOJS should work fine, but for this course, we'll be using Node. Throughout the course, we'll be taking a look at how to create a solid base for your ExpressJS applications, how to pull in data from external services, and how to get that data to your users in real time. As well as that, we'll cover advanced ExpressJS tips, how to secure your application, and finally, how to ship it to production once it's done. We'll be taking a look at popular Node modules, such as nconf, Winston, and Helmet during the course. We'll start by bootstrapping an Express application with configuration options and context-aware logging before moving on to integrating external APIs. If you're familiar with Express, but want to learn how to scale your code base whilst adhering to best practices, this is the course for you. Following that, we'll be writing some tests for our application to prove that it works as expected before we integrate SocketIO, to provide our users with data in real time, and leveraging its functionality to provide a simple chat room for our application. Next up, using nconf, a configuration management tool for Node.
Welcome back. Hopefully you've had a bit of a break since section 1 and you're eager to start building something with the Instagram API. In this section, we'll be looking at configuring our application to connect to Instagram and pull down the latest popular images. We'll be creating a page to show these images. And finally, we'll incorporate a cache memory to reduce the number of requests to the Instagram API. In this video, we're going to be registering an application to use with the Instagram API. installing a module from npm to help us access it, and making the call to the API to see what information it returns for us to use. Firstly, we need to register an application. This will allow us to access the Instagram API. Visit instagram.com/developer. I'm already logged in, but you may have to create a new account or log in the account you already have. Click on Manage Clients, then register a new client. Give your application a name and a description. Now, the website URL is the URL where the application would be deployed, but now since we are still in development, let's just give it localhost. And our application runs on port 8000. Then give a redirect URL. This is where the users will be redirected to when they log in using their Instagram. Here, I'm giving it localhost:8000/oauth/done. Press enter, fill in the CAPTCHA, and click on register. Congratulations! You have successfully registered on Instagram application. Now that we have created an application, we have two pieces of important information that will need to request data from the API: client ID and client secret. These are used to identify our application when we authenticate against the Instagram API, which is OAuth2 API. We could just write all the code to deal with the API ourselves, but instead we'll use npm to install the Instagram Node module and use that. If you want to have a look at the library we're using, you can find it on GitHub. Reading the code of modules that you use is always a good exercise to assess quality and make sure they do what you need. As always, we need to require the module and configure it. Let's start by opening app.js. We write var ig equals require Instagram node dot Instagram. You may notice that it says .instagram at the end of our require statement. If you're interested in learning why, take a look at the factory design pattern. Next, we need to configure it. In this situation, that involves using the client ID and the client secret that we obtained earlier. That authorizes us to make requests to the API. So let's start by pulling down the most popular images at the moment and logging them to the console. To do this, I use ig_media_popular. If you want to know more about the functions that we will be using, documentation is available in the Instagram Node project's README file on GitHub. Now that we've got that, let's boot our application and see what happens. As you can see, when the application boots, we see the data almost immediately. Good job! We just authenticated with the Instagram API and grabbed the most popular images. That wasn't too hard, was it? Today, we started by registering an application with Instagram's OAuth2 API. Then, we installed Instagram Node to work with it. We wrote 6 lines of code to authenticate with and pull data from the Instagram API. One of NodeJS's biggest strengths is npm, and with the wide variety of packages available. Fortunately, most of them are very easy to use with Express. Next time, we'll write a bit more code, so instead of just showing the return data, we'll actually show images on the page inside our application. In the previous video, we managed to connect to the Instagram API and pull down a list of the latest popular images. In this video, we'll be creating a page in our application that shows those images for our users to view. We're going to start by taking a look at the data Instagram returns for us. Then, I'll show you how to create a new page to show the results. And finally, we'll get the data that we receive onto the new page. Let's create a new page in our app called Popular. We'll access it by going to localhost:8000/popular. We start by creating our root. To do this, let's copy the index root and change how it behaves. Instead of rendering index.html, we want here to render popular.html. As this is a new page, we'll also need to take care of creating the templates that will be used. So let's create view/popular.html. That's what will tell our route that we are loading. Just like last time, we make sure that it extends layout.html. Then we define the block content. We just say, hello, this is the popular page. We can change this later, but for now, let's just see how our route works. To have our application serve this route, we also need to tell it that it exists. So we start by editing app.js. And jumping down to line 20, we'll say var users equals require ./roots/users. We are just going to take a copy of that and change it to var popular equals require ./roots/popular. This requires our route, but it has not been loaded by the application yet. We need to dump that into app use, which is on line 68, and tell it where to mount this route. I'm just going to say at /popular mount, the popular route that we just required. That should be all we need for our application to know about a route. If we start our application and visit /popular, we can see our page. Great, it works. As the basics work, let's hook up our Instagram API, request to the page, and show some of the images. We need to move our Instagram code from app.js to our popular route if we don't want to make the call every time our application starts. So let's edit app.js and routes/popular. We have removed the require Instagram node and IG use and moved them into popular.js. We do the same with the call to media_popular. We don't actually want to call media_popular whenever this route is loaded. We only want to call it whenever someone visits /popular. So let's move it into the handler. Now we don't want the console to log the data either. To start, we will loop over all the images and output the URL to the images on the page. So let's delete console.log media and create a loop. Media is an array of objects, and each object has an images key, which contains another key, standard resolution, which contains a URL. Here, we just loop over every item in media and push the image URL into our URLs array. Now that we have the data, we want to pass that to our page. First, we need to pass the data to our templates. And then we need to update our templates to render it. So let's delete all the standard content and put the URLs into curly braces. This is a Nginx construct for rendering variables. We use URLs because that's what we called it when we passed it into our templates. As igmedia_popular is an asynchronous call, we need to move res.render inside the callback. Otherwise, it will be called when we have no data available, and it will cause an error. Let's take a look at what we have done. If we go to our application and refresh the popular page, as you can see, our page now shows a list of URLs that are separated by a comma. This is progress, but we really want to show actual images on our page. We need to change data that our route passes through to our view. Instead of a string separated by commas, we want to pass the raw array of image data through. Then, we need to ID our view to call with this. So we delete the URLs, and instead, we add a for loop. Inside the for loop, we have an image tag that outputs each URL with the width of 250 pixels. To do this, we use the for construct in Nginx. For and if are two of the most important building blocks for all of our templates. So, we say for each URL, In URLs, create an image element that shows the current URL. For and if work in the same way they do in JavaScript, just with a slightly different syntax. If you want to learn more, you can check the templating docs. That should be all we need to show our images. So let's restart our application, jump over to the browser, and visit our popular endpoint. There we have it, all of our images shown on the page. Instagram returns an array of image objects that we can get data from, and it's really easy to render data on page with Nginx. However, you may also have noticed that it made our application quite slow because we had to hit our Instagram API on each request. In the next video, we'll take a look at how we can cache those requests in memory and speed up the page's response time. Welcome to the final video of consuming services. So far, we've connected to the Instagram API and we are showing the results to our users. In this video, we're going to implement an in-memory cache so that we don't have to hit the Instagram API for every request to our application. We'll now cover how to implement an in-memory cache, how to use a cache instead of going to Instagram, and how to make items in there expire automatically. It's worth mentioning that the cache will only be used for as long as our app is running. If we wanted to persist the cache across restarts, we'd use something like memcached or Redis. Let's start by editing our popular route. To get the data, we need to make a call to ig.media_popular. To make it easier to add the caching, let's start by writing a function that wraps the call. All it does, whenever we call get_most_popular, is make a call to ig.media_popular. Most of the data route use this function instead. Now let's add our cache to get our get_most_popular function. We create a popular cache variable that we'll use to store the results of our request. We make a call to ig.media_popular. Store the variables in popular_cache before calling the callback. To do this, we need to change our call to ig.media_popular. For now, what we do is create a closure and return callback, air media limit. Next, we need to cache any return data in popular_cache. So in the callback for media_popular, we populate popular_cache with media and limit. Finally, we want to avoid the call to ig_media_popular as much as we can. To do that, we check if popular_cache.media exists. If popular_cache.media exists, we immediately return the callback with the media and limit from the cache. Let's check if our cache works. We start our application and visit the popular route. The first time it loads, it might take a second or two, but each time we refresh the page after that, it comes back instantly with the same images, in the same order. As we're now using the cache data, the popular page shows almost immediately after we refresh it. This cache will work for as long as the application is running. If we restart the application, we'll make the request to Instagram again. Now that our cache is working, we want some way to expire the data in there. Here, I'm testing a timeout of 5 seconds, but I advise you set it to 60. Next, we need to change our popular_cache and how we store the data within it. When we store media in a limit, we also want to store a timeout. What it does is it gets the current date's timestamps. Now, for our timeout, we multiply 1000 to it, and the reason why we multiply by 1000 is because we want to specify our timeout in seconds. Hence, the new date in JavaScript returns milliseconds by default. Finally, we need to change when we check if the date was in the cache. Now, date within our cache is not enough. It also has to be in our timeout. What we do is, we say get the current date and get the time, and if that is less when the date and time is out, let's just return it. Otherwise, Let's carry on and fetch it using the Instagram API. Let's have another test of our cache logic now that we have added the timeouts. Let's restart our application and visit the popular page. Again, the first time it takes some seconds, but each time we refresh, it comes back instantly. If we wait a couple of seconds so that my 5 seconds timeout expires, we see we got new images again, and these are cached for 5 seconds. Let's recap what we've learned today. We can use an in-memory cache to store results from API requests so that we don't have to re-request the same data repeatedly. By storing the request time, we can make the data expire every 60 seconds, and it dramatically speeds up our application's response time. So, let's recap what we've done so far in our ExpressJS application. We started out by creating a new application and installing the Nginx templating language, Winston for logging, and nconf to manage our configuration options. Then, we connected to the Instagram API so that we could show the most popular images currently inside our app. Finally, we added a cache to the request to Instagram to speed up our response to users. This is quite a lot of code for us to just trust that it works fine now. So next time, we'll be taking a look at Mocha, a testing tool for JavaScript, so that we can prove everything works as expected. Welcome to Section 3 of Mastering Express Web Application Development, Proving It Works. So far, we've managed to install some useful libraries and build a small application with them. In this section, we'll be installing Mocha. It's a JavaScript testing framework. We'll also be writing our first test, refactoring our application. This means we'll be improving its internal structure to make them easier to test. Mocking, i.e., writing some tests for our application. Installing Sign-on.js, which is a standalone test spies. Stubs, and mocks for JavaScript. We'll be using test spies in this section. In this video, we're going to write some tests to prove that the code we've written works as expected. To do this, we are going to use a testing framework called Mocha. In this video, let's install Mocha. Mocha is developed by TJ Hollywoodchuk, who is also the creator of Express. We'll also install ExpressJS, an assertion library, and we'll write our first test. So why do we need to do this? Our code might work now, but what about now as time? How about a month's time? Or maybe a year's time? By writing tests to prove that the code is doing what we expect, we can be sure that our application will continue to work so long as we make sure that the code always passes our tests. This is especially important when we start to collaborate with other people, as it allows them to make changes, knowing that they can just run the tests and make sure that they have not broken anything else. First, we need to install Mocha. We'll install it globally like the docs tell us to with npm install-g Mocha. Be aware that you might have to install with sudo or as an administrator if the privileges of your Node.js install aren't correct. In addition to Mocha, we'll need an assertion library to use. In this case, we'll use ExpressJS, which we'll install into our project. Now that we have it installed, let's make sure that Mocha works. To do this, we'll create a test that does not depend on our application code and run it. This is the test taken from the Mocha documentation. So let's save our file and just run Mocha. As we can see, the tests pass. Next, let's update our assertions. Whilst we could use the assert library, personally, I find ExpressJS much easier to read. With asserts, we assert equals -1, an index of 5 in 1, 2, and 3. With ExpressJS, we expect 1, 2, and 3, index of 5, to equal -1. It reads a lot more like the English language, which is why I find it easier. If you want to go on using assert, feel free, but I'll be using expect for the remaining of the tests. As we've changed our tests, we need to run them again to make sure that everything is still passing, which it is. Great. Our tests are running. All of our tests passed first time through. So let's add a test that is intended to fail to make sure that things are working correctly. We'll make it really simple. Let's just say that the number 1 is expected to equal the number 7. Obviously, this isn't true, so when we run the test, it will fail. Once the test has failed, we can change the number 7 to 1 and run it again to make sure that the tests pass. As all our tests pass, let's delete our 2 example tests so that we're ready to start writing tests for our application next time. Mocha allows us to define expected behavior for our code coupled with ExpressJS, which allows us to assert that the expected behavior is actually what happens. Our tests help us to prove that things work as expected, both now and in the future. In the next video, we'll be performing a little refactoring on our application so that we can test things more easily. In the previous video, we installed Mocha and made sure that we could run a test. Before writing any tests for our application, we need to perform a little refactoring to make things a little easier to test. In this video, we are going to look at splitting our code into an Instagram module that we can call from our application. We are going to carry on using this module so that our application works as intended. And we'll also take a look at how this refactoring will help us in the future. Let's refactor the code in our popular route a little bit. We are going to start by splitting out our function into 2 methods, one that uses the cache and one that just accesses the data on the Instagram API. The reason that we are splitting this function into 2 is so that later on, we have the choice of either getting the freshest data all of the time or going via the cache if we need to. When accessing the cache, we just need to check if our data is in the cache. Otherwise, defer execution to get most popular. Things are starting to get a little bit messy in our application now, so I think that it's about time that we split our code into multiple files. Let's start by removing our data access code from our root. We'll make a lib folder and create an Instagram module in there. This is where we'll put all of our cache logic. Just like before, we require the Instagram node module. Then we create IG, which is going to be our wrapper object for the Instagram API. When we create this object, we pass in our client's ID and client's secret, and it takes care of configuring the Instagram node module. We've added a couple of additional functions, such as getClientID and getClientSecret, just in case we need them in the future. But hopefully, functions like getMostPopular and getMostPopular with cache will look fairly similar. What we've done is the logic where we test. If the media is in the cache, we've extracted this into another method so that we can test it again later. Otherwise, this is exactly the same code that we had in our popular route. This code is available on GitHub, so take a look on there if you want to put it in your own app. Now that we've extracted the code into a module, we need to update our application to use that new module. First, we need to require our new library. Then, we need to create a new instance of it. Here, I'm passing my client ID and client secret. Then, we have to update our route to use this new module. I updated to get IG, which is what I called my new Instagram instance. Get most popular with cache. This is because I called the function in our module get most popular with cache. Now that we've updated all the calls, we should test our app by hand again to make sure that it still works. So we start our application and visit the popular page. And after a few refreshes, we are still in the cache. But if we wait a couple more seconds, it goes and gets us a new set of images. Although it doesn't feel like we've accomplished very much in this session, we've actually made some major steps towards making our application testable. We can replace the module with something that returns static values if we want to test just the rendering section of our app, or we can call the module in isolation to make sure that it returns the correct data without needing to worry about any of the rendering side of things. In the next video, we'll be taking a look at a technique called mocking that we can use to make our code return the same information for every request instead of hitting the Instagram API. Welcome back to Mastering Express Web Application Development. In the last few videos, we've installed Mocha and done a little refactoring of our app. In this video, we're actually going to write some tests. We'll make them simple for now, as the app isn't that complicated. We're going to write two tests, one that makes sure that the credentials in our module get set correctly, and another that makes sure that when we request data, we receive what we were expecting. The first test that we write will be quite straightforward. We start by creating a test/Instagram.js. First, we need to require ExpressJS and our Instagram module as our test needs them as dependencies. Next, we need to create a new instance of our module as that's what we're going to test. Where we previously passed in our client ID and client secret, we pass in simple strings so that we can assert that what we passed in is what we get out again. We are going to be testing our credentials, so let's create the describe block that says the credentials. Let's write our first test. So the credentials should return the correct client ID, and we expect the Instagram get client ID to be some ID. It's very straightforward.
Let's have the same for our client secret. The credentials should return the correct client secret.
Expect IG get client secret to be some secret. That's the same as what we passed in right at the beginning. So let's run our tests. They both pass. As our tests pass first time, let's purposely break them to make sure that they are valid. So if we change it so that we expect our client's secret to be some secret too, which it isn't, because we have passed in some secret, our tests should fail. And there it is. The credentials should return the correct client secret. Error, expected some secret to equal some secret too. So let's fix our tests and save. Our tests run again. And there we are. 2 tests passed in 7 milliseconds. Next, we want to write a test for getPopularMedia method. So here we test everything that we can. We expect error to be null. We expect media to be an object. That's about everything that we know at the minute. It's important to note that IG getMedia most popular is an asynchronous function. In our it definition, we have to pass the done callback to the function and then call that when the test is done. Without this, Mocha will assume that our tests run instantly in a synchronous way and mark everything as a pass. Let's run our tests and see what happens. As we can see, we have a failing test. Expected error to equal null. That is what we said in our tests. Expect error to be null, but instead, we've received an error that says the client ID provided is invalid. This is because we provided some ID and some secret to our new Instagram, rather than providing valid credentials. Let's create an instance with valid credentials so that we can run this test. Here, I've created a new one called IG2, and I've updated our test to use this. Really, I should put the credentials in our IG instance and update the existing tests. But as we're short on time, I'm just going to create a new instance and run the tests. This time, we can see that our tests run because error was null and media was an object. However, the test took 700 milliseconds to run, and it went all the way to the Instagram API to fetch the data. This is where mocking comes in useful. So I'm going to delete our second Instagram instance on the original Instagram instance. I'm going to replace the getMostPopular function. By doing this, I stop it calling the Instagram API, and I know exactly what data it's going to return. So if we go and run our tests again, it should now pass. Even with the invalid credentials, it will never actually hit the Instagram API. What our function returns matches what our tests expect. An error is null, and our media object is an object. So let's run those tests. And all three passed. As we know what data is going to be returning, we can increase how efficient our test is. Here, I've added 2 lines. I expect media to equal data incoming, and I expect limit to equal 3. I can safely do this as those are the values that I specified in our mock function. Again, if we run our tests, everything passes. Let's break our tests just to make sure. We expect limit to equal 5, and run our tests again. And they fail. Error, expected 3 to equal 5. So let's undo that and save our file. And now we have a base set of tests for our library. We have a mock function in IG getMostPopular. This stops it hitting the Instagram API, meaning that our tests are reproducible and faster. Then we expect error to be null, media to be an object, there is data incoming, and limit equal to 3. Being able to inspect data like this is one of the advantages of mocking your inputs. It may not seem like we're testing much of our module yet. After all, we're telling it what values to return, then making sure it returns them. However, now that we have some tests that pass every time, we can start testing the advanced functionality like the cache system that we've implemented. Unfortunately, we're out of time for this video, but in the next one, we'll be taking a look at proving that the correct methods get called when we ask for data, using a library called SignOn.js. See you next time. Welcome back to the final part of Section 3, Proving It Works. Previously, we installed our testing framework, mocked some functions, and written tests to prove that things work as expected. In this video, we're going to be taking a look at SignOn.js, a tool for spying, stubbing, and mocking methods. Let's take a look at installing SignOn, using it to prove that our cache method is actually called, and also using it to prove that methods are not called when bypassing the cache. As we are going to be using a new library, the first thing we have to do is install it with the npm install SignOn. If you're interested, you can read more about SignOn on its website, but it might be easier to use it in our test code and then read the documentation once you know what each thing does. So let's start by loading up our test file. I'm requiring SignOn. We're going to write a test that proves that our fetchFromCache function is called each time we make a call to getMostPopular with cache. This is a way that we can prove that our cache is being used. So let's create a new test. It should call fetchFromCache when loading via the cache, In this test, we make a call to getMostPopular with cache. The first thing that we do is set up sign-on to spy on our Instagram module and the fetchFromCache method. What actually happens here is that sign-on wraps our method with another function and adds some additional properties to it. One of these additional properties is callCount. Here, we expect our Instagram fetchFromCache callCount to be 1 once we call Instagram getMostPopular with cache. We also need to make sure that our function is marked as done and we can run our tests. And that thing passes. If we go back and change this to 0, saying that we don't expect fetchFromCache to be called when we call getMostPopular with cache, and run our tests again. As we can see, the tests fail, as our call count is 1 and not 0. This is good, as we expect fetchFromCache to be called whenever we call getMostPopular with cache. One important thing to consider is that our tests have a global state. Signon.spy is now spying on IG fetch from cache forever. To go around this, we can use Mocker's before each syntax to create a sandbox and clean up after ourselves each time. So, before each, we create a new sign-on sandbox, and after each, we restore everything back to its original state. This means that we have to update our tests to use this sign-on rather than just sign-on. But that's all. Before each and after each, we'll now take care of keeping sign-on tidied up. We can also use sign-on to make sure that if we call getMostPopular without opting into using the cache, the call to fetchFromCache is never made. So here, we say that we should not call fetchFromCache when loading without cache.
Again, we set up our signon.spy.
But this time, we call getMostPopular, which you'll remember from an earlier video doesn't make a call to fetchFromCache. So we expect id.fetchFromCache call count to be 0. Again, we need to tell Mocker that we are done with this test inside the asynchronous callback. So we run our tests. We just tested that fetchFromCache is called when we expect it to be called, when we make a call to getMostPopular with cache. We also prove that it is not called when we don't expect it to be called. Sometimes, testing parts of our application that work transparently, such as our cache, can be quite difficult, but sign-on makes it nice and easy. We've used sign-on to assert that something was called or not called. However, we can do much more than that. As we'll be asserting that something was called, we can assert that it was called with specific arguments. We can use it to test XML HTTP requests, create fake servers, and even fake time. This is especially useful when you've timeouts in your application and you need to test them. We can also use sign-on to create stubs and mocks. Stubs are just like what we created for our getMostPopular function, where it returns the same data every time. And mocks are a slightly more complicated version of that, where we can assert that we expect our stub to be called once or twice or a certain number of times. We can also assert that we expect to be called with certain arguments and things like that. That was a little bit of a whirlwind tour of sign-on, but we did what we set out to do. We proved that the cache is only called when we want it to be. Sign-on has a much richer feature set than this, and can be used for mocks, stubs, and even controlling time. Unfortunately, those are out of scope for this video, but I urge you to have a read at signonjs.org. Next time, we'll be starting a new section of Mastering Express Web Application. It will be centered around real-time communication, and we'll be adding a live comment system to the popular images that we pull in.
Welcome back. Hopefully, you've been playing around with Mocha, seeing what else you can write tests for, since we covered that in the last video.
In this section, we'll learn how to install SocketIO. It is a JavaScript library for real-time web applications, handling data in real time for our application, scoping data to individual users. We'll build a basic chat system for our users, adding onto the chat system and making it a public chat room.
In this video, we're going to be installing SocketIO. SocketIO is a real-time communication library. It contains server-side and client-side components, and we can use it to deliver information to our users in real time when they connect to our application. Thanks to libraries such as SocketIO, NodeJS is fantastic for real-time communication. Adding a real-time aspect to any app can help impress your users. SocketIO acts as an abstraction layer on top of technologies such as WebSockets and long polling, the technologies used to provide real-time functionality to websites. First, we need to install socket.io from npm. As always, we can just type npm install socket.io. Once we have SocketIO installed, we need to hook it up to our HTTP server. We do this so that we have access to the SocketIO assets that we need on the client side. So let's edit bin www. This is our entry point to our application. We jump to where we create our HTTP server and move that to the top of our file. The reason we need to do this is because we need the server when we require SocketIO, as it's passed as a parameter to the require statement. As well as configuring SocketIO, we'll add a handler that triggers each time a user connects so that we can make sure things are working as expected. Here, we just console log that a user has connected. Next, we need to configure our client-side code to include the SocketIO library. So let's edit layout.html. Now this confused me for a long time, but you can just require the SocketIO path without copying it anywhere. Our HTTP server will intercept the request and serve up the relevant JavaScript. So let's add that to the bottom of our HTML body. Now that we've added our code, we can test that it works. So let's start our application and visit it in a web browser. If we flick back to our application console, we see that a user has connected message appears. This means that SocketIO was configured correctly. That's all we needed to do to get SocketIO installed. As it's such a popular library, the installation instructions have been tested over and over to make it as easy as possible for people to get it up and running. Our application doesn't do much for now, but in the next video, we'll take a look at how to send data back and forth between the client and our app. If you prefer, there are other options available, such as SockJS, Fay, and raw WebSockets. However, I have only ever used SocketIO and have been very happy with it. So, I'll see you in the next video, where we'll be sending and receiving data in real time. We're going to dive straight into things in this video, as I'm sure you can't wait to make our app send and receive data in real time using our SocketIO install that we set up last time. In this video, we're going to be adding a comments page to our app for each image. We're going to make those comments appear as they're posted in real time. First, let's add a page to our app where we can view a single image. This will be the focal point of our real-time component. I'm going to add it to my popular route. Here, I say when we make a GET request with a popular/any string, which I'll capture as ID, we want to render the single page. Let's create that view. Just like everything else, views or single.html extends layout.html, and it has a content block. For now, we just say single page inside that content block. That should be enough for our route to exist. So
Let's start our application and browse to the page. Here, the ID is 1234 and, as expected, it shows single page. We'll also need to update our Instagram module so that it knows how to translate between an ID and a path to an image. So let's edit lib/instagram.js and add a new function. Get_media_from_id just loops through everything in the cache, and if the ID provided matches the ID for that piece of media, it returns just that piece of media. Now that we have this functionality, we can make our single page work. If we go back to our root, we can add a call to ig.get_media_from_id, and we pass in rec.params.id, which is how we read from the URL. Now, we need to realize that there'll be an object containing a specific ID, or it will be false. We'll also need to pass the state of root to our view. Now that we are passing that data forward to the view, we can update our view so that it no longer says single page. But instead, if the media exists, if our function doesn't return false, we show the image, otherwise we say, sorry, we couldn't find that ID. And finally, we need to update our popular page to link through to a single image page. To do this, we no longer want to send URLs to our popular page. But we need the ID as well. So instead, we send the entire media object. We have to update our view to go with this. So instead of saying for URL in URLs, we say for mform in media. And we update it to say m.images.standard_resolution.url, which is what we did in our loop, in the root before. But now, instead, we're going to do it in our view. We also want to make a link. So we say a href popular m.id. Now, each image will link to the single view page for that image. Now that we know that works, let's go back to our view. And on the single page, what we'll do is create a ~ul greater than, which we'll use later to show comments later. Let's give it an ID of comments. This actually won't do anything yet because we haven't implemented add comment or any receivers to receive the new comment event. Let's do that next. If you were wondering why we changed the name of the event that we emit each time by appending the message ID, we do this so that it means that we can listen only to messages that we're interested in on the client side and ignore all the rest. To help with the client-side implementation of this, I'm going to be using jQuery. So I'm going to edit my layout view and just require jQuery from the Google CDN. As we depend on jQuery and SocketIO, we need these to be loaded before we add any of our own custom scripts. To get around this, we can define another block in our layout. Here, I've defined a block called JS. At the minute, it's empty. But what we can do is define this block in our templates. In this case, I'm editing single.html. And I'm just adding alert hello to make sure that it works. Let's test our application to make sure that the alert shows. So if we load the popular page and then choose an image to view, we see that our alert pops up. This means that our new block is working. Now that we know that the JS block is working, we can start adding our actual application code to it. Here, I add a new event listener saying that whenever we receive the event's new comment image ID, we want to create a new li element with the text message.content. Remember, message.content comes from the event the SocketIO image. We want to append that to our comments list. Listen to any new comments being sent by the server. Unfortunately, the server will never send any new comments as we don't have any way to tell the server that we've posted a comment. To do that, let's add a form next to the image. This is a very simple form which just contains a text area and a submit button. Now we don't want to submit this form like we normally would using a post request. Instead, we want to intercept that message and send our message using SocketIO. Here, we say that on the form submit event, we want to emit a SocketIO event called add comment. Remember, we added a handler for this in our application earlier. We sent the ID of the image and the content of the message, which is the value of the text area, with the ID of m. We then reset the value of the text area to nothing and return false to make sure that the form doesn't actually submit itself. That's all it takes to add a real-time comment system to our app. There's a similar API on the server and on the client. Each time you want to send data, you need to emit on a specific topic, and anyone that is interested in that data can listen on that topic. Unfortunately, these messages only exist temporarily whilst in transit and are not persisted anywhere. We'll take a look at how we can persist them in a later video. Next time, we'll be looking at sending data to a specific user, which will form the building blocks of our chat room example. Welcome back. Last time, we added a commenting system using SocketIO. In this video, we're going to continue looking at SocketIO, and our topic for this video will be scoping data to individual users. We'll be adding a mechanism that allows us to send messages to specific users based on their username. To do this, we'll be using SocketIO's Room functionality, which makes message scoping very easy. As this is a new piece of functionality, we need to register a new route with our application. First, we require routes and chat. Then, we mount this module at /chat. We also need to create the route and views for this route. So edit routes chat.js. All this does is at /chat, it renders the chat view. Let's create that now. Just like everything else, it extends layout as a content block. And as we're going to be writing JavaScript for this view, it also has a JS block. This is a good opportunity to make sure that our route actually works. So let's start our application and now get /chat. As expected, we see the words chat room. This page is going to have two components. The first is a form where we specify a username. The username is how each user will be identified. The second will be a form that they actually use to chat to each other, which contains an input for who you want to send the message to and a text area for what you actually want to send them. Let's start by making our username select component work. To do this, we'll write a bit of jQuery that will intercept the form submission and emit an add user event. Here, whenever we submit username-form, we emit the add user event and then hide the username input form. We also want to set my_username. My username will be used later when we actually send some messages. Now that we are sending the add user event, we need to add something to our server handler. So let's edit bin www Go then to our io.onConnection block. Here we say socket on add user, and then we say socket.join data.username. What this does is it creates a SocketIO room with the name contained in the data username and adds the socket to it. In this context, socket is the specific socket that belongs to the user that sent the message. Our chat form takes a very similar format to the rest of the forms we've created so far. Whenever we submit a message, we emit a new event and stop the form submission. Here, we call socket.emit. The topic is send message, and we send the username from and some content for the message. Then we clear the two content fields from the form and return false. As always, we need to tell the server how to cope with a new sent message event. On the server side, we will look up the username provided in our object to work out which socket we need to send the data to. This works because each user joins to a room that is named the same as their username. We just forward the entire payload onto the user and we'll work out how to render it on the client side. SocketIO knows to send just to this room, as instead of using IOEmit. We use IO.2. IO.2 scopes a message to be sent to only a specific room. Once we've set which room to send to using IO2, we can then call emits just like normal with a topic and a payload. In this case, we emit with the topic new message and the payload data. I'd like to mention here that the implementation that we're working through should not be used in production. It trusts all user input and needs additional sanitization and checks before we can use it. This video is designed to give you an idea of how to start implementing the feature, leaving the additional work down to you. So, let's hook up a new message event. Whenever we receive a new message event, we'll just append a new list item that says who the message is from and show the contents of the message. That's all it takes to set up our chat system. So, if we start our application and visit the page, I'm setting up my username as Michael, and I'll send a message to myself. Note that that works. Let's open it in a couple more tabs. I'm going to add Bob and Sue. I'm going to say, "Hello there" to Bob, and it appears on the screen, but not on Sue's. I'm going to say, "Hello Sue" to Sue, and it appears on Sue's screen, but not on Bob's. And of course, they can also reply to me. As you can see, messages are only sent to the intended recipient. If you specify a username that doesn't exist, no message will be sent at all. I'll leave that as an exercise to the viewer to send a message back to the sender saying that the user does not exist. Hopefully you can see how, by using a room, we can send targeted messages to specific people. All you need to do is make sure that the people are in the correct rooms. We used one person per room, but there's no reason you can't have 2, 3, 4, or even 100 people per room. This is the final building block before we can start to use SocketIO to build a fully fledged chat room for our app, which is something that we'll take a look at in the next video. Welcome to the final video of section 4, adding a chat room. In this video, we'll be building on top of all the things we've learned so far in this section. In this video, we're going to be building on top of our chat system from the last time to create a public chat room. We're going to look at adding people to multiple rooms so that we can support private and public chats. To create the chat room, we'll reuse the chat page that we created the last time, as well as joining them to a room that is the same as their username. We'll join them to the channel called public, which everyone will receive. Let's do this in the Add User event now. To mark a message as public, we'll just leave the To box empty. If it's empty, we'll send it to everyone. We need to add a check on the server to populate the channel name if it's empty. So in the sent message event, we'll say that the data username is the same as data username if it exists, or we set it to public if it's empty. Let's make sure that this is shown on the page as well. That's actually all there is to it. If we start our application and visit the chat page, I'm going to say that I'm Michael again. And if I send a message to Michael, then it shows up that it's a private message. However, if I leave the To blank and send a message, they are not marked as private. This is because they are going to the public channel. But if I specify a recipient, it's marked as private. Because we did all the legwork last time, setting up rooms and sending messages to each person, this was very little effort. By using rooms, you can easily control which users see what content. In SocketIO, everything is just a room. By using creatively named rooms, you can have a mix of public and private chat without too much effort. That's the end of our Getting Real-Time section. Hopefully, it was nice and easy to follow along, and you're full of ideas of how to use SocketIO to improve your existing apps. I would like to stress, though, that the code in these videos is just demo code and needs a lot of work before it's safe to ship. In the next section, we'll be focused on Express again a little bit more, and we'll be taking a look at more advanced concepts such as middleware and mounting sub-applications. Welcome back to Section 5 of Mastering Express Web Application Development. We'll be diving back into Express and taking a look at some of the more advanced features. In this section, we'll be making use of middleware to make our life easy. Let's dive into the first video of this section, middleware. In this video, we'll be taking a look at middleware and how we can use it to add functionality to your application. We'll be covering Express and its support for middleware, how we've previously used middleware in our application without even knowing it, and how to write a piece of middleware that will execute on every request. Until version 4, Express was built on top of a library named Connect. Connect provides a wrapper around HTTP.server and adds a few extra features, one of which is allowing the server object to use a set of middleware. Express version 4 removed Connect but maintains an API-compatible interface that we can still use. Middleware are functions that take a request and a response object, perform an action, then pass on the request to the next function in the list. We can write our own middleware. Middleware is just a function with a specific signature, the request object, our response object, and a next callback. Let's create our middleware that runs on every request just to see how it works. Let's set up our app and add some middleware. If we search for app.use, all of these are instances of middleware being registered, things like logger, things like body parser, and even when we register our routes, these are all examples of middleware. We'll create a really simple middleware that logs the current request method and the URL. So what we do is we create a function with a signature, rec, res, and next. Perform our action, which in this case is console.log, and just the string, middleware, with the request method and the request URL, and then we call next. We need to call next to allow Express to move on to the next registered middleware. If we start up our app and visit a page, we can see this middleware running. Middleware can be registered at any point, but it only takes effect on any routes defined after you register the middleware. I'll demonstrate this. We'll move our new middleware after our first endpoint. Now this middleware should run when we access users, popular, or chat, but it shouldn't run if we access our home page. So let's restart our app and visit our home page. As you can see, the line that starts the middleware doesn't show in our logs. However, if we visit the popular page and check, it does show. This is because we registered it after we defined our home page route, but before we registered our popular route. In addition to middleware being dependent on when it is registered, you can also pass it an optional parameter that provides a base path for the middleware to run on. If the URL doesn't start with the string that you provide, the middleware will not be run. So let's update our middleware so that it only runs on the popular page. Yet again, we start up our application. If we navigate to our chat page, we see that it doesn't appear in our logs. But if we visit the popular page, we see that it logs middleware is a GET request and a request to /. The request path is just / because we mounted the middleware at /popular. So for example, if we choose an image, the middleware now registers get/id. The actual URL is /popular/id, but because we mounted at /popular, that part is removed from rec.path. If you provide a path when you are registering middleware, it will run on all paths, if that is well. This is the reason that /popular/id works, rather than the middleware just running on /popular. If we really wanted to, we could replicate Express routing's functions using middleware too. As we have access to the entire request object, we can check if it's a get to /foo or a get to /bar. As we can see, this works just like it does when we use app.use. In summary, middleware can be used to do some really powerful things, as the request and the response objects are shared throughout all of the middlewares called. Any modifications you make in a middleware are persisted all the way through the request. If we register multiple middlewares, they are all applied one after another in the order that they were registered. That means that the order in which we register middleware is important. In the next video, we'll be taking a look at mounting sub-applications using Express, which means you can develop your site in a very modular way and just plug all the sub-applications together to create your final application. Hi, and welcome to the second video of this section. In the last video, we looked at how we can use middleware in our applications. In this video, we're going to be taking a look at mounting sub-applications. This is very similar to what we've been doing all along when we create new routes, but in this video, we'll take a more detailed look at mounting applications. We can also take standalone applications that we write once and then use them in every application that we write. Let's start by creating a new application. We'll make a very simple one. We'll create a lib/sub.js. And it's the simplest application that we can think of with Express. What we do is require Express, create an application, register root at /, and then say, this is our sub-application. Then we need to make our application listen on port 3000. So our application is listening on port 3000. And if we visit it, it shows this is our sub-application. This is a fully functioning ExpressJS application. Let's remove the app.listen, as we don't want this application to run independently. Instead, let's export the app so that we have access to it. We're going to mount it as a sub-application of our main application. To do this, we need to edit app.js. We can search for app.use. As you can see, we've done this before. We've mounted things at a certain route. Here, we just add another app.use. I've chosen to mount this application at /sub. The second parameter is the application to mount. Here, I've just directly required it, but you can always store it in a variable and choose to use the variable in the call to app.use. Technically, our sub-applications are just middlewares that match a specific path. We learned about middlewares in the last video. Let's make sure this worked. So we start our application and visit the home page. As you can see, we're in the main application here. If we visit /sub, it triggers a request to our sub application and shows the message for the home page for that application. This works because we mounted the application at /sub. Although we put together a very contrived example, hopefully you can see how this could be useful in more complex applications. It's important to know that mounting applications uses the same mechanisms internally as registering middleware. This means that our application is the same as a middleware. It is true because it follows the same function signature: request, response, and next. You can write your functionality once and then just mount it at a specific URL in your application whenever you need it. Imagine that you have a user management system that handles registration, logging in, and profile management. Instead of writing this for every project you build, you could just write it once and then mount it as a sub-application in your projects. In the next video, we'll take a look at how we can inspect request headers and return data in the correct format for AJAX requests. We're halfway through section 5 now. We've learned all about middleware and mounting sub-applications. In this video, we'll be taking a look at serving content conditionally, depending on if the incoming request has a flag set. To say it's an AJAX request, we're going to take a look at how to detect if a request has been made via AJAX, how to return data in a different format if it is an AJAX request, and how to write a middleware that'll make life easier when we're dealing with an AJAX request. In this video, we'll be making changes to the popular page. By default, the page renders all the images. This is great for when people first visit the page, but if we wanted to expose the data to another app, it's not in a very easy to consume format. Instead of sending back the images, if it's an AJAX request, let's just send back the data as JSON. So let's edit our popular route. jQuery adds a special header to all of its AJAX requests, which we can use to send back raw data instead of a rendered page. Request headers are accessible via rec.headers, so we can check rec.headers x requested with. We do this before we render our HTML page. If it's set, we return the data, which will be JSON encoded. Otherwise, it renders our popular page just like normal. So if we start up our application, we use curl to make a request to the page, and we're expecting to see HTML, which we do. Now, if we make a request again, but this time we set the x requested with header, which jQuery will automatically set for us, we expect to see JSON data. As this is such a common header, Express has built-in support for it. So instead of saying if rec headers x requested with equals XML HTTP request, we can just say if rec.xhr. If we make our request as normal, we get our HTML back, and if we make it with the request, we get the JSON as requested. As well as the x requested with header, we'll also add support for sending an accepts header to explicitly say that you want JSON. So now our code says, if it was an XML HTTP request, or the person making the request has explicitly asked for application JSON, let's send them JSON. This time, we're going to set accept. And as expected, our application sends back JSON. as we've told it that we only accept an application JSON. Let's just test if we made a request without a header. It still returns our HTML, and it does. Things are still working as expected. As this is something we might want to do fairly often, let's write a small piece of middleware to set a new property on the request object if the user has requested JSON. So let's edit app.js and jump down to app.use. And before we register any routes, we'll register a piece of middleware. This is just the same as the if statement that we wrote in our route. If rec.xhr or rec.headers except is application JSON. Then we set a new property on the rec object. We set once JSON to true, and then we call next to carry on with the rest of our middlewares that we've registered. Now, in our route, we can just use rec.onceJSON, and this will return true if either it's an XML HTTP request or the user has set the accept header to be application JSON. After making that change, let's make sure that everything still works. So start up our application. We'll start by making a request with X requested with, and as expected, we see the JSON. Next, we try application JSON. And again, as expected, we get the JSON. And finally, we'll make a request without any headers, and this time, we're expecting the HTML, which is what we see. So, anywhere in our application that we want to return JSON if the user requests it, we can just now use if rec.onceJSON, rather than having to handle the XML HTTP request and the accept headers separately. This is a great use of middlewares, and is similar to the kind of things that you'll be doing. As you can see, conditionally sending different data depending on if certain headers exist is fairly trivial using Express. X requested with is a common header to indicate an AJAX request. Express takes this one step further and creates rec.xhr for us. This is a helper set on rec. In addition, we talked about jQuery today, but it is also used in lots of other JavaScript frameworks, such as Angular. In the next video, we'll take a look at the final part of this section, data persistence with MySQL. Welcome to the final video of Section 5, Advanced Express. In this video, we'll finally be adding a persistence layer so that we can add persistent comments to our application. First, we're going to connect to a MySQL database in NodeJS. Then, we're going to model our data using Sequelize and NodeJS ORM. And finally, we'll integrate this new data store with our existing Instagram application. The first thing that we need to do is create a database that we'll use in our application. You'll need MySQL installed for this, so if you don't, pause the video now and go and install it. I'm going to create a database called Mastering Express. If you'd prefer to use a GUI, such as SQL Pro or PHP-MyAdmin, feel free to use that instead. We'll be using Sequelize, a Node.js library that wraps MySQL and provides an ORM interface. First, we need to install Sequelize. We'll also create a folder that will contain our models. As Sequelize supports Postgres, MySQL, MariaDB, SQLite, and MS SQL, we'll also need to install the MySQL drivers. This is because Sequelize doesn't bundle any database drivers with its own package. Otherwise, we'd be installing the drivers for Postgres, Maria, and all the other providers when we don't need them. Before we create any models, we'll need to add some code that runs database migrations before starting our app. This ensures that our database always has the correct structure when our app starts. So, let's edit bin www. Before we start our own server, we want to run models.sequelize.sync, and then, when that's complete, we'll call server.listen to start our application. The models.sequelize.sync is provided by Sequelize, and .then is a promise. Promises are similar to callbacks in that they help with the asynchronous nature of JavaScript. Models doesn't exist, so let's jump to the top of this file and require it. This line will require the models module that we created. We need to create an index.js file in the models folder that this require statement will load. So let's do that now. So let's edit models index.js. This code has been taken directly from the Sequelize documentation. You can read more at docs.sequelize.js.com/en/1.7.0/articles/express. We do need to make a small change to this for our application. We don't have our configuration inside the directory. We just have config.json for the top level. We also don't have all the different environments in our config file. So instead, we're just going to say, in the config file, look in the database section. This code connects our database and loads all the modules that we've put in this directory into an object that we'll use later. We do need to edit our config file though. Sequelize requires a username, a password, and a database to access. Here, I'm using my root user with no password, which is not recommended in production, and the database name is Mastering Express, which is the database that I created right at the beginning of this video. Let's create a model to represent our comments in models/comment.js. We use sequelize.define to define any fields and data types that the model has. In this case, the comment has two fields, ID and content, both of which are strings. If we save this file and restart our app, we see that Sequelize is executing a create table statement. If we access the database, we can see that the comments table has been created and that it has 4 fields. By default, Sequelize models have a created at and updated at, plus it has ID and content, which are the 2 fields that we specified. We need to update our single root to load any comments for that image from the database. To do that, we use the findAll command with a where clause. So here we say find all comments with the ID stored in rec.params.id. Then when you find them, emit a SocketIO event for new comment, the ID of the image, with the payload being the entire comment object. SocketIO, this message looks exactly the same as the message that happens when we add the new comment. Next, let's save the posted comments to the database so that we can repopulate the page once people refresh. To do this, we need to make a small change to the add comment event on the server to save the database as well as forwarding the content to all connected clients. Our SocketIO code is in bin www. And the first thing that we need to do is set global IO equals IO. Ideally, SocketIO was a module that I could require, but for now, setting global IO equals IO means that IO is in scope in our popular route when I use it. Next, I need to persist the comments of the database. To do this, I use models.comment.create, and I pass in the two fields that it's expecting, ID and content. I'm also going to move the io.emit call into the then callback. This means that the message will only be emitted once. It's being persisted through the database. We also need to add models to this file so that we can use models.comment later on. The reason that didn't work is that the SocketIO events are being emitted before the page can be rendered. To fix this, what we can do is set a timeout. This means the SocketIO events won't be emitted for 500 milliseconds after the comments are fetched from the database. This should be enough time for the page to render, and for SocketIO and the client to connect to the server. Let's see if that made any difference. So our comment was posted, and if we refresh, it appears again. Great! We wrote a lot of code in this video, but a lot of it was just boilerplate for connecting to our database. The Sequelize documentation is good, and creating new models is fairly straightforward. All you have to do is define your data types, and Sequelize will take care of the rest. Sequelize creates the tables and provides an easy API for adding and retrieving data. Now that we've added one model together, why not have a think which other models you could add to your app? That's it for the Advanced Express section of this course. In the next section, we'll be kicking off with security and taking a look at how to use HTTPS connections with ExpressJS.
Welcome to section 6 of this course, Security. Let's dive straight into this section. This is perhaps the most important section of them all, as it's focused on security. We're going to start by adding SSL to our application. The first step towards making any application secure is to make sure that no one can listen in on your communications. This means running your app over HTTPS, which happens to be our first video. To do this, we're going to be generating SSL certificates, making Express listen on SSL using our certificate, and terminating SSL using Nginx so that our app only has to talk HTTP. To secure your application, you first need an SSL certificate. I've generated a self-signed certificate for this demo, but you'll want to purchase a certificate from a reputable certificate authority. If you do want to generate your own certificate for development purposes, you can use the following script. What this does is generate a private key. Then it generates a certificate request. And then it uses the private key to sign that certificate, generating a public certificate. The private certificate is what proves that you are who you say you are, and the public certificate is used to send to the receiving client so that they can verify that you are who you say you are. If you're interested in reading more about SSL, there is a good introduction located at https://timnash.co.uk/guessing-SSL-questions. Once you've run these commands, you should end up with several files. The two important ones are masteringexpress-cert.pem and masteringexpress-key.pem. NodeJS's HTTP module supports HTTP out of the box, which we will use to retrieve our requests and send them onto our app. So let's start by editing bin www, which is where we set up our servers. As you can see, we require HTTP, but now we also need to require HTTPS. We need FS as well, since we need to read the contents of our private and public key files. Here, we read our private key in our certificate from the files on our desk, and then we populate our SSL options hash. This is something that the HTTPS module in Node.js is expecting. Once we have all this information, we can create a new server as well, just like we did. Server equals http.createServer. We can do server SSL equals https.createServer. We provide our application that we are going to run, but we also provide this SSL options object, which we created just now. This is how we know how to sign our requests to prove that we are who we say we are. Now that we have a server, we need to make it run. So just like before, where we did the server.listen, and then we write the HTTP port from nconf. This time, we're going to do server ssl.listen, and we're going to read a different value from nconf. We're going to read HTTP port SSL. So if we start our application up, we can now see the HTTP config has a new entry. So edit app.js. Search for HTTP. We'll set port SSL to be port 3003, so by default, our application runs on port 3000 for HTTP and port 3003 for HTTPS. But if you remember, our application doesn't run on port 3000 because we set a port in our configuration. Let's add port SSL to our config as well, and we'll say for HTTP it runs on port 8000, and for HTTPS it runs on port 8003. So if we start our application up, we can see now that the HTTP config has a new entry, SSL, that has the value of 8003. We can visit our application on port 8000, but if we try to visit our port 8003 over HTTP, it just doesn't respond. If we change this to HTTPS, the application responds instantly. The reason that it says that this is untrusted is because the server certificate is not trusted. The reason for this is because I'm using a self-assigned certificate. Whilst we run our application like this, it's not the most reliable way to do it. The recommended way to run Node.js applications using SSL is to let something else take care of the SSL portion of the request, as whilst the SSL support in Node.js is functional, it is not as performant as other options. In this case, we're going to use Nginx. So let's write our Nginx config. Here, I create a new server block, and what I say is they should listen on port 8081. SSL was enabled, and we find it with the public certificate and private key of our SSL certificate. This is so that the Nginx server can identify itself with us and to all the traffic. Finally, I set up a location block, and it just says, any requests to this server, I want to set a few additional headers, and then I want to pass off any handling away to our app. At this point, Nginx is taking care of the entire SSL configuration, and it's just a plain HTTP request. So when we use proxy pass to pass off to our app, which I've defined here, our application is receiving a plain HTTP request. Our app is known as an upstream. What that is a collection of hosts and ports for requests before we. In this case, I just want to forward the request onto 127.0.0.1 port 8000, which is where our HTTP application is running. One thing I did forget to do is tell proxy pass which protocol to use when passing after our app. Here, we're telling Nginx that it will be an HTTP request. We save our configuration file and we load Nginx so it picks up the new config. If we start our application, we can see that it's running on port 8000 and 8003. And if we visit our application on port 8000 over HTTP, it responds like normal. And if we hit our application on port 8003 over HTTPS, This result is going directly to the HTTPS NodeJS server. But if we hit port 8081 over HTTPS, this result is hitting the Nginx, and it forwards our request onto the Node.js application. As you can see, all three options work, but terminating SSL with Node.js at Nginx is the most efficient solution. As we know how SSL supports by using Nginx, I'm just quickly going to remove all of the SSL support from our Node.js application. Now, we'll be able to access our application over HTTP on port 8000 and over HTTPS on port 8081. Port 8003, which was Node.js handling the SSL connection itself, no longer works. Enabling SSL is the first step towards making our application secure. SSL ensures that all communication between our app and our users can't be intercepted. Express and Node.js can handle SSL, but not as efficiently as other servers such as Nginx. Next, we'll be taking a look at how we can prevent cross-site request forgery. Fortunately, there's middleware available to make it really easy. Welcome back. In the previous video, we secured our application with HTTPS, taking the first step towards developing a secure application. This time, we're going to take a look at preventing CSRF. In this video, we're going to be implementing the cross-site request forgery middleware, which will help us verify that any requests that modify state in our application come from inside our application. To do this, we'll have to look at what CSRF actually means, how we can protect against it in Node.js, and we'll update our application so that it's protected. So what is CSRF, cross-site request forgery? Or as I'm going to refer to it from now on, CSRF, is a method of ensuring that all requests are created legitimately. Without it, people can craft forms on third-party sites that send requests to our application to perform an action that a user might not be expecting. The way that it works is that we generate a random string and store it in the user's session on each page we load. We then put that string as a hidden field in the form, and when the form is submitted, we make sure that the string sent by the user matches what is in the user's session. If it doesn't match, we reject the request. First, we need to install the middleware. Fortunately, this is as easy as npm install CSRF. This middleware adds a rec.csrf token function to make a token which should be added to requests which mutate state. You can use it for post and get requests, but we'll be focusing on post. Now that we've got our CSRF installed, we'll need a form to protect. I'm going to edit my popular route and add a new route to it. All this route will do is that it will return a new view. We also pass in the value of the username input from the form that we want to show on the next page. So let's create that view. So we create a content block, write our form, and end our content block. This is a really simple view that just contains the form. If we start up our application and try visit the form page, we notice that we get an error. Sorry, we couldn't find that ID. This goes back to routes being the same as middlewares. what happens is that our router is matching this path because /form also matches /id. This is just the same as what happens with middlewares and the order in which you define them. If we move our get/form to before this definition and then attempt to access a page, the form shows up as expected. If we try and submit something through this form, we get a 404 not found. This is because we registered our route as a GET request and we're trying to post to it. Let's go to our routes to handle this. So what we need to do is just define our function as a variable, and then we can pass it to a router definition. So now router.get/form and router.post/form, both of them are handler functions. I also made a mistake earlier when I set to use rec.body.username. If we take a look at our form, we actually send a greeting. So let's update that now. Let's update our view to use this greeting. Now, if a greeting is provided, it will greet me. Let's give it a go. So if we start our application and go to the form, it greets me as expected. Now that we have a form that we can secure, let's add CSRF to that section. So let's go to app.js and then to app.use. What we need to do is to first require the CSRF middleware and register that. And then we register another middleware, which is where we check for a bad CSRF token. If the error code doesn't match, we just pass it on to the next registered handler. Otherwise, we send it back a 403 with an error message. As we're not using any session middleware and instead we're using the cookie parser, we need to tell CSRF about this. To do that, we just set cookie to true when we require and use the middleware. If we start up our application and try and submit the form, we see that we get the session has expired or has been tampered with error message. This is because we didn't put the CSRF token in our form. It must have the value CSRF, and we populate the value by passing in a variable. We need to update our popular route to pass this through. Here, we pass in rec.csrf token as csrf token and send something through the form. We get hello Michael instead. This shows that our csrf token is being populated. We can check this by viewing the page source, and you can see it generates a random token that will be sent through with our request. That's it. CSRF is a really simple way to improve the security of your application. Fortunately, the middleware provided by Express takes care of all the heavy lifting for us. Adding CSRF to all our forms means that we can be sure that all requests to our application come from inside of our application. For the final part of this section, we'll be taking a look at Helmet. Helmet is a set of middlewares for Express that will help to secure our application. Welcome to the final video on security. In this video, we'll be taking a look at Helmet, a collection of middlewares that can make our application more secure. To use Helmet, we have to install the npm module. We're going to take a look at the middlewares it provides that can help us to protect our application, and how to use some of the middlewares that it provides in our application. At its core, Helmet is just a set of middleware that sets the relevant headers to prevent some potential security risks. As an example, the Xframe middleware will prevent our application being loaded inside a frame set or an iframe. There are middlewares available to help control with cross-domain policies, cache control headers, HTTP strict transport security, and many more. There are so many options, it's worth reading up on what they all do on the project's GitHub page. As always, first we need to install Helmet with npm. Then, we need to edit app.js and require it. And as it's a middleware, we need to register it with our application. Just using Helmet will enable all of the middlewares with their default settings. This is enough for most people, but you can customize the middlewares used if you need to. If we start up our application and make a request with curl-i, we should see all the headers being added by Helmet. As you can see, x-xss-protection, x-download-options, x-frame-options, and x-content-type-options have all been added. These are all headers that are expected by common browsers, and they've all been added automatically by Helmet. If you wanted to allow your app to be shown inside an iframe, but only on the same domain, you can use just the Xframe middleware. So instead of just using app.use helmet here, I'm saying app.use helmet.xframe with the same origin as a parameter. Of course, if you wanted to specify any other middlewares, you'd need to specify those as well. Using this method requires you to specify the middlewares one by one. If we start up our application and make a request again, we notice that this time Xframe options is set to the same origin, but all the other options like x-xss protection are missing. Using Helmet is an easy way to make our application a little more secure. It can help protect you from frame-in-frame attacks, cross-domain requests, and much more. However, we still need to make sure that we don't allow our users to perform things like cross-site scripting attacks. But Helmet does do a lot to help us. In the next section, we'll be taking a look at how to ship our application to a production server. Hey guys, welcome to section 7 of this course, which is called Shipping to Production. We're getting quite close to the end of our series now, but we've still got a few sections left. So far, we've managed to build a small application, write a few tests for it, and write some real-time functionality. This time around, we're going to be taking a look at improving our application's performance with NodeJS cluster. We're going to take a look at how to ship our application to production. More specifically, we'll be using Cluster, a core Node.js module. We'll integrate it with our app before considering if Cluster is the correct tool to achieve what we need. Cluster is a core module that spawns multiple child processes using childprocess.fork. That communicates with a master process via IPC. This is an experimental feature of Node.js. Usually, a Node.js process will only use one core, meaning that we're not using all of our available CPU power. Cluster allows us to spin up multiple processes to take advantage of all the cores, whilst still sharing the same server ports. We don't need to npm install Cluster, as it's a core module. So let's just require it in our application's bootstrap. So let's edit bin www. Under the top, we'll just do var cluster equals require cluster. When using cluster, the script knows if it's the master process or the child process. We can use this to only execute our application in the child processes. In the master process, we have to tell cluster to span child processes. Typically, you want to spawn one child process per core available. To do this, we use the core module to detect how much capacity we have available instead of having to hard code a value. We don't need to require our application and all our models each time we load the cluster master process. So instead, we move these require statements to after cluster.isMaster. We say, if the cluster is the master process, count the number of CPUs available and fork child workers. Otherwise, do everything else. If we start our application now, we can see each log message multiple times. This is because it shows once per child worker. The final part of the code that we need to add is a listener for any child process exiting. If this happens, we just want to log it and spawn a new worker. Let's start our application and take a look at running NodeJS processes. I'm going to kill process 80904. I'm expecting it to show up in my logs, saying that the worker died and was restarted. As we can see, worker number 6 died, and we spawned a new worker, and the new worker executed everything that a normal worker would when it was starting up. You might be wondering why we're using the cluster module rather than just spawning multiple instances of our application ourselves. We use the cluster module as it allows all of our sub-processes to listen on the same port. Our master process receives requests and passes it off to one of the child processes to handle. Unfortunately, cluster is considered an unstable part of Node.js. Because of this, we're going to remove it from our application by undoing all the changes that we made this time. Don't worry though, we'll do something similar in the next video, using more stable technologies. Whilst we design our application to run as asynchronously as possible, sometimes we need to perform some synchronous operations. When this happens, having multiple event loops available is a big boost to our application's response time. Cluster allows multiple processes all to listen on the same master port, which gives us a way to add more capacity to our application with minimal effort. Next time, we'll take a look at how we can do something similar using multiple instances of our application, but we'll use Nginx to load balance across them rather than using the cluster module. Welcome back to Mastering Express Web Application Development. This is the second video of the section. It's called Nginx and NodeJS. Last time, we used cluster to create multiple event loops for our application. In this video, we'll be using Nginx to load balance across multiple instances of our application instead. Back when we were setting up HTTPS for our application, we configured Nginx to pass off the request to our application instance. Thankfully, it's really easy to modify this config to load balance across multiple instances. All we need to do is add the host and port to the upstream block. Here, I'm running another instance of our application, running on port 8001. Next, what we have to do is make sure that we have instances listening on those ports. So, let's start an instance on port 8000. And an instance on port 8001. I then save our Nginx configuration file and reload the configuration. Each time we hit our application via Nginx, it should go to one of our two instances. Nginx will round-robin the incoming requests across our running applications. Let's take a look at it in action. As we can see, so far, neither of our instances has received a request. But if we make a curl request to the home page, we see that our instance running on port 8000 has received a request, and the one running on port 8001 hasn't. If I make this request again, we see that port 8000 hasn't received another, but instead, it was sent to port 8001. If I make another request, it goes to port 8000, and another to port 8001. Personally, this is how I run my applications in production. The cluster module works, but as we're already using Nginx for SSL termination, it makes sense to use it for load balancing too. If we need additional capacity, we can create more instances of our application, add them to our config file under upstream. In the next video, we'll take a look at Supervisor, which is a tool that we can use to run our application and make sure it restarts should the process die for any reason. Hello, welcome to the last video of section 7. Now that we've got our application deployed, we want to make sure that it continues to run forever. There are a few options for this, including tools such as Upstart, Forever, or PM2. Today, we'll be taking a look at a tool called Supervisor. In this video, we're going to use Supervisor to keep our application running 24/7. To do that, we're going to install the tool and configure it to monitor our application. So what is Supervisor? Supervisor's website says that Supervisor is a client-server system that allows its users to control a number of processes on Unix-like operating systems. More generally, it is a way for us to start our application and have another system monitor it to make sure that it continues to run for as long as it's monitored. If it crashes in that time, Supervisor will restart it. It's important to note that while Supervisor can be used on Windows, it requires Cygwin, which is fairly complicated to set up. You can generally install it from your system's package manager, such as apt-get, yum, or any other package manager. However, the version of Supervisor in the repos through a lot of distributions is heavily out of date. So, when using Supervisor, I prefer to install it through pip, which is the Python package manager. To ensure that Supervisor has installed correctly, we can run which supervisor control. Once Supervisor is installed, we need to generate a default configuration file. Thankfully, Supervisor ships with a command to do this. So we run echo_supervisor d_conf, and then we pipe that into a utility called t. It reads from a standard input and writes to a file. In this case, we write to /etc/supervisor d.config, which is where a supervisor will look for its config file. A lot of this file is commented out and won't actually take any effect. We're going to just run with the default configuration with one small change. If we edit our configuration file and then go to the bottom of it, we need to uncomment this include section. Then, we change the path in the middle include section that it looks for files to include in. In this case, it will be /etc/supervisor.d/ anything ending in .conf. Now that we have Supervisor installed and configured, we can run Supervisor D to start our Supervisor instance. If we run Supervisor control again and pass in status, we can see that there's no output. This is because we haven't defined any applications for Supervisor to run yet. Let's define an application for Supervisor to run now. First, we need to create our etc supervisor.d directory. Then, we can create a file inside that. We're going to call it instagramapp.conf. supervisor configuration files are fairly easy to follow. They're in any format. So at the top, we see a heading and we say that this program is called Instagram app. Under this heading, we have a command. This is the command that supervisor will use to run our application. We need to provide full paths to both the node binary and our application bootstrap. This is because supervisor runs as root generally and doesn't have a lot of locations in its search path. There are a lot more options available, including how many times the app should be relaunched and how long to wait between the app dying and it being relaunched, and where to store the log files. You can find all of these options on the supervisor website. Once we've created that file, we can run supervisor control reload to restart supervisor. And now, if run supervisor control status, we can see that Instagram app is running and has been running for 4 seconds. If we want to see the logs for this, we can run supervisor control tail-f Instagram app. This should look familiar. We initialized nconf and our application is running on port 8000. If we hit our application, we should see that appear in the supervisor logs. This happens because supervisor just logs the standard output of our NodeJS application into single processes or groups of processes. I've edited Instagram app.conf. Once previously, I had programmed Instagram app. I've renamed that to program I1. I've also added program I2, which is the same application but running on port 8001. Finally, I defined a group called Instagram, and I've said that in the Instagram group. I've programmed I1 and I2. If we restart supervisor and then run supervisor control status, we can see that I1 and I2 are both running now, and that they are in the Instagram group. If I restart just one of them, and then run status again, we can see that it's been running for 3 seconds, whilst Instagram I2 has been running for 25. We can also restart the entire group. This will restart I1 and I2. This is very useful for when you have multiple instances of your application and you want to perform a new release. You can ensure that all instances are restarted and the new code is loaded in one command. To make sure that the supervisor does restart our application when it dies, let's kill it. Here, we can see that our system is running 2 node processes, which is what we are expecting. If we kill process ID 9095 and run supervisor control status, we can see that I2 has only been running for 6 seconds. If I kill 90958, which should be Instagram I1, we should see that restarts as well. I1 is starting up and has been running for 5 seconds. Thanks to supervisor, we can be confident that even if we made a mistake and there is an uncaught exception somewhere in our application, it will be restarted the instant that the process dies. You might be more familiar with Forever or PM2, similar tools that are written in Node.js. Whilst they work, I like to have my monitoring infrastructure written in a different language to my application, just in case anything goes wrong with Node.js. That brings us to the end of our Shipping to Production section of Mastering Express Web Application Development. Next time, we'll be taking a look at the final section of the series, Larger ExpressJS Applications. Welcome back to the final section of Mastering Express Web Application Development. In this section, we're going to be taking a look at a few open source projects that are built on top of Express to see how people are using it in the real world. The first one that we're going to look at is ghost.org. Ghost is a Node.js and Express Power blogging engine. We're going to take a look at how the application is structured and what libraries they use. Ghost is an open source project with lots of contributors from all around the world, with varying levels of expertise. If you want to get involved in open source, Ghost is a good way to do it. First, let's clone the Ghost repo. As Ghost is open source, you can just clone it from GitHub onto your local machine. The first thing that I'm going to ask you to look at is how big the project is. To do that, I'm going to use a utility called clock. What this does is it counts the project and generates matrix. As we can see, this project is quite large, containing 39,000 lines of JavaScript at the time of publishing of this course, along with 1,600 lines of HTML and 4,500 lines of CSS. Let's compare that with our Instagram application to just get a sense of the scale of the project. Here, I say I want to exclude the Node modules directory because I don't care about all the code in there. I didn't have to do this in the Ghost directory as we haven't run npm install yet. Our Instagram application is considerably smaller, with only 280 lines of JavaScript, including the code that Express generated for us. Compared to Ghost's 39,000 lines of JavaScript, our application is tiny. Let's take a look at package.json. If we scroll down, we can see all the dependencies that Ghost has. As you can see, Express is one of the many dependencies. It also uses Express handlebars for templating. It also uses some other common Node.js modules such as Chalk for coloring the console output, Lodash, which is utility framework, Passport, which is used for user authentication, and Request, which is used for making HTTP requests. If we take a look at index.js, we can see that the start command on line 25. This tells us what the entry point into the application is. So, we see that Ghost returns Ghost server, and then we call start on Ghost server. So, here we see that Ghost is actually just a variable containing the exports of core/index.js. So let's take a look at that file. This is just a bootstrap script. If we scroll through this file and get to the bottom, we can see that it just exports an initialization function. What's interesting is this middleware function where it passes in the blog application and an admin application. Again, middleware just points to middleware/index.js. So let's take a look at that. In middleware/index.js, we start to see app.use. What this file does is registers middleware on the application. This is a concept that you should be familiar. Back to the core/index file. Let's take a look if we can see where our application is created. If we search for Express, we can see the initialization function that it creates two applications, one for the blog and one for the admin section. There's quite a lot going on and we don't have much time, but if you're interested, you can scroll through this file and see how the configuration is loaded and models are initialized, how templates are rendered, compression is set up, and how things like View Engine are configured for Express. Now, let's take a look at the important things in the project. The most interesting start with most applications is its routing. Ghost has 4 different router files. Let's start by taking a look at the front-end routes. At the top, we can see we require front-end, which is a collection of front-end controllers. We'll come back to this. If we scroll down, we can see that we have an index router, a tag router, an author router, and RSS router, and a private router. Initially, we set up a few routes such as logout, sign out, and sign up, and then we redirect to other URLs. These are done for historical purposes and backwards compatibility. If we keep scrolling down, say to RSS router, we see that we visit /RSS/ as a GET request. We'll execute the code in the front-end controller with the RSS function. Scrolling down, we see that if we get /, we'll execute code in the homepage function at the front end. Let's take a look at controller's front end to see what these routes are actually executing. Again, there's lots of setup done at the top of this file. If we jump to line 251, we find a large object that just contains handler functions, each of which has that familiar request, response, next signature that we're used to. Again, things aren't too easy to follow here, as the controllers are just responsible for calling commands that are required in and reformatting that data into the format required by the views. If we scroll down, we can see that a pre-post render event is fired, and then we render a post passing in the request and response object. Speaking of which, where are the views? Let's open index.html. This is the main template for our application. If we scroll down, we can see that it looks fairly similar to Nginx, but we are actually using a templating engine called Handlebars. Now, Ghost's interface isn't actually rendered by Express the majority of the time. This original page is. Then the application is an ember.js application. So, if I search for the team user view, we can see that the team user view is actually an Ember view declaration. What I actually need to search for is teamuser.handlebars, which contains the HTML function for this view. All of these views are fed using that Ghost API. So we can search for routes API and take a look at all of the available routes that are used. As I mentioned, Ghost is a fairly large project, so we can't cover all of it here. But if you're interested, I'd take a look at the Core Server Models folder and Core Server API to see how things work behind the scenes. The models and the API form the core of Ghost. Ghost is the first Node.js project that we've taken a look at, and it's a big one at that. It's the best example of a multi-collaborator Express codebase available today. So if you're looking for inspiration, it's definitely worth getting involved. In the next video, we'll take a look at balloons.io, a much smaller application that's a chat room built with SocketIO. Welcome to part 2 of larger ExpressJS applications. In this video, we're taking a look at balloons.io, a chat room built on SocketIO. We're going to take a look at how the application is structured, what libraries they use, and just how different it is from ghost.org, the blogging platform. Just like last time, the first thing that we do is clone the repository. Once the repository is cloned, we can run clock to see how big the project is. As we can see, an 8,500 lines of JavaScript. Much smaller than Ghost. It's still 10,000 times bigger than our little Instagram application. Just like last time, we'll open up package.json and see what Node.js modules are used in this project. Right at the top, we see that it uses Express, although we should note that it uses Express 3 and not Express 4 like our application. It also uses Redis and Passport, the authentication system that we saw in Ghost. You notice that it depends on passport-Facebook, passport-Twitter, and passport-GitHub. This is because Balloon supports logging in with Facebook, Twitter, and GitHub. Thanks to the README, I know I need to look at balloons.js, which is our bootstrap file for the project. Here, we generate an application, require our config, and pass in our application. The pattern of passing in an application is fairly common. This means that your modules that you require can modify a global application state. Carrying on, we can see that we require strategy, which is to do with passport authentication, and then we require routes. Now, let's look at routes. If we scroll down, things start to look familiar again. We have a request, response, and a next. We find some routes for authenticating first with Twitter, then Facebook, and then GitHub. And then we find the logout route. Next, we find our application route. As you can see, having everything in one file makes things much easier to find. However, at a certain point, such as with Ghost, having all your routes in one file just isn't maintainable, and you have to start splitting them out. Back with our routes file, we notice that when we make a GET request to /rooms, we actually call utils.getPublicRoomsInfo to fetch the data, and then we render room_list. If we carry on going down our routes, we find a post request to /create, and again we delegate to utils module to make sure that it's a valid room name. Make sure that it doesn't exist, and create the room. Now our final route, /id, where ID is an identifier for a room, and again we delegate to utils to get the information about the room. Get the user's status, and enter the room. Now, let's take a look at the utils file. Utils does a lot of work making sure that a room exists, loading an online user list, and other associated actions. If we scroll down to the function that was called last in the routes file, enter room, you'll notice that there is also a res.render call in there. Normally, res.render would be called from the root, but in this application, it's called from utils. This is possible because utils has access to the request and the response object. This utils file is fairly similar to the controllers folder that we saw in Ghost. But instead of exposing entire handlers, it just exposes single functions that the handlers use. As the actual application for Balloons is quite small, the logic must be elsewhere. Remember when I mentioned that it also uses SocketIO? Let's take a look at sockets.js and see what's going on. If we scroll down, we start to see things about authentication and configuration and sockets for events and my message events. This is where all the functionality that we were looking for is implemented. Things like sending a message and changing status are handled here. SocketIO waits for requests to come in, then propagates those changes to Redis before sending the data out to all other users. Let's keep scrolling down and see what else is there. History request. Let's take a look at when this is called. Again, this app uses quite a lot of JavaScript on the front end. This time though, there are no frameworks to be found. It's all just jQuery. If we search for history request, we see that it appears in public/js/script.js. Here, we see that it is emitted on the connective end of SocketIO, and it's only emitted if there have been no chat messages sent so far. This makes sense, and it is a much more elegant solution than our hack of waiting for half a second before emitting events to ensure that the socket is connected. Doing it this way, the client notifies the server when the socket is connected and is ready to receive data. Let's take a look at the history request event. So, back to SocketJS and history request. What it does is it spawns a child process which reads the end of a file on disk and populates the chat box so that the user can see his history. Even though Balloons is a smaller app, we still can't cover all of it. We've covered the main points, but if you're interested in user authentication, take a look at the top of sockets, the authorization, and also strategy.js. As you can see, we've taken a look at two Express applications, and they both look very different. This is both a pro and a con for Express development, but hopefully you saw some similarities between both Balloons and Ghost, and our application. Balloons is a good example of how you can integrate Express with tools such as SocketIO when it comes to things like user sessions and authentication. Unfortunately, this is the last video in the series. I'd just like to say thanks for sticking with me all the way through, and hopefully you've learned something about developing Express applications along the way. If you've got any questions, feel free to email me at m@michaelheap.com and I'll get back to you. Again, thanks for making it this far.